Hey everyone, in this video we are talking about the chain rule and how to apply the chain rule when you're taking derivatives. So the first thing you need to remember is that you only need to use the chain rule when you're dealing with a composite function. So an example of a composite function would be sine of 3x. It's sine of some sort of thing multiplied by x. It's not just x by itself. Or the log of 3x squared would be an example of a composite function. Even the log of x is a composite function because you're taking the log of some sort of unknown. So let's do one with sine x first of all. Oh, an example of something that wouldn't be a composite function would be like 3x, and that's not composite just because it's just a number being multiplied by x. So that would just be 3 times whatever the derivative of x is. It's not something like f of g of x, where there's sort of one function nestled inside another function. So let's do an example with sine, a composite function using sine. So let's do sine of 2x. So sine of 2x equals our f of x. So we want to find f prime of x. So the first thing we do is take the derivative of the outside function. When I mean the outside function, I mean it doesn't matter what's in here, take the derivative of what's not in the brackets. So in this case it's sine. The derivative of sine would be cosine of whatever's in the brackets. We don't know yet. Now in the brackets was 2x, so the first step is cos 2x, and then we multiply that by the derivative of what was inside the brackets. So the derivative of 2x would just be 2. So this will become cos 2x times the derivative of 2x is 2, and we would just write that as 2 cos 2x. So you can do the same if this is cos and you want to find the derivative of it. It doesn't matter which trig identity it is, you need to apply the chain rule. Let's do one where we've got exponents. We have f of x equals to 100 1 plus x squared to the power of, oh sorry, that 100 was actually just the exponent. Okay, so we've got something in brackets to an exponent. We don't care what the thing is in brackets at this point. We take the derivative without needing to know what it is. And so, to take the derivative, that would be 100 times whatever's in the brackets to the power of 99. So what was in the brackets was 1 plus x squared, so we'll just fill that in, and then we need to multiply by the derivative of what was in the brackets, 1 plus x squared. The derivative of 1 is 0, the derivative of x squared will be 2x. So this will be 0 plus 2x. So this will simplify down to 100, 1 plus x squared to the 99 times, we don't care about the 0, all we need to multiply by is 2x. Okay, so then we think we also need to multiply by the derivative of, we still have an x there, so we can go one more step, the derivative of x. So we have 100, 1 plus x squared to the 99 times 2x times the derivative of x is 1. So now we've taken the derivative so many times that we're not left with the last number. It doesn't have an x in it. We've got rid of all the x's. So now all we do is simplify what we have. I'm just going to take the 2x and combine it with the 100. 2x times 100 would be 200. X And then we have 1 plus x squared to the 99 times 1 doesn't change anything, so we'll just leave our answer like that. Let's do one that uses the natural logarithm. So I think we'll do two. First we'll let f of x be log of x, and then we'll do one where f of x is log 2 of x. And so, first thing, we don't care what's in the brackets. If we take the log of anything, we know from our formula that's 1 over whatever the thing was in the brackets. In this case it was x. So it'll be 1 over x times the derivative of what was in the brackets. The derivative of x is just 1. So this will be 1 over x times 1 will be 1 over x. So the derivative of the natural logarithm of x is 1 over x. If we had f of x equals log of 2x, f prime of x would be, we don't care what's in here, the log of anything is 1 over whatever that thing is. In this case, it was 2x. And then we have to multiply by the derivative of whatever was in the brackets. The derivative of 2x would just be 2 times the derivative of x is 1, so that would just be 2. So that would be 1 times 2 on the top over 2x. Your 2's will cancel out, and you'll be left with 1 over x. So the derivative of log of 2x is 1 over x. Now the inverse of the natural logarithm is e to the x. So let's do a question where we use the chain rule with e to the x. And so the way to take the derivative of e to the x, you might see it written as e to the power of u times u prime. So that's what we're doing here. What that means is the derivative of e to anything, so if we'll take the derivative of that, is e to the, we'll let u equal the 3x, it's e to the same thing times the derivative of whatever the exponent is. So we'll get e to the 3x times the derivative of 3x, well the derivative of x is 1 times 3, that would just be 3. So we'll be left with 3e to the 3x.